All right, guys, this is lesson 5.2 on medians and altitudes in triangles. Our learning target is for you to be able to find missing information using properties of centroids and orthocenters. So here's some new vocab words for us. Just as a reminder, we didn't do constructions, but this is what a median is. Normally, we would talk about these in constructions also. But a median is a segment inside a triangle that connects a vertex and the midpoint of the opposite side. So let me just draw a picture to see if I can kind of make that make a little bit more sense. So it's inside a triangle and it connects the vertex and the midpoint. So if this is the midpoint, that means these two are the same. It connects those. And then we could call this like A, B, C, D. And then if we draw another triangle, but just kind of shaped a little differently, if we went from this one to the median of the opposite side, this is the middle, it means these two are equal. That would be our median. So if we name this EFG, and that's H, then BD and FH are medians. So again, it's from basically the corner to the middle of the other side. The corner to the middle of the other side. Those are the medians. Well, when you cross all three of those, so there's another one that goes from here to the middle of this side. And then there's another one that goes like, it'd be like this. You don't need to draw this, it'll get kind of messy. There'll be another one that goes from here to the middle of this side. And what you'll see is they cross here in the middle. That spot that all three of them cross, I'm going to take all these little markings out here. The spot that they cross right here is called a centroid. So a centroid is a point of concurrency where the three medians in a triangle intersect. So there's been a lot of vocabulary between 5.1 and then now 5.2. I put together a document for you guys to look at. You might not find it helpful, but you might find it helpful. I kind of try to break down what the parts are, but we're talking about different points of concurrency, and the centroid is when the three medians cross. And then the thing that's interesting or like useful about the centroid is the distance. What it says is if P is the centroid of triangle ABC, then AP, so this right here, is 2/3 of AK. And same with the other ones, like BP is 2/3 of this guy. And then CP is 2/3 of the full line. So normally when we're in school, I'll kind of have a running list on the board of the different words that we're looking at and why it's useful. But I'm going to just draw a little picture here. So the way I like to think about this is there's three spots on this line. So A is the vertex. This is the vertex. And then P is the centroid, or like the middle, the point of concurrency. And then K is the side. So K is back on the other side. And what's true about these two segments, and this is what's interesting, is that this from the vertex to that middle point is 2/3 of the length, and this is 1/3. So for example, if we had a line that was, I don't know, 9 units long, that means that this section would be 6 and this section would be 3, because this one's going to be twice as long. Okay, so that's what's useful about that. I guess the interesting piece of information. Next, we're going to talk about altitudes. So An altitude is a segment from one vertex of a triangle to the line containing the opposite side. The segment or altitude is perpendicular to the line containing the opposite side. So I'm going to show you, I guess, 3 different kinds of triangles. So there's one that a lot of people think of, which is almost an equilateral. So if we call that JKLM, then KM would be one of our altitudes. Next kind of triangle that we would have is maybe it's just kind of slanted off, like pushed off to the side a little bit. And we'd call this NPQ. And then if we drop this straight down at 90 degrees, that is R, then PR is an altitude. The way that I think about this is if I were to stand right up here and drop a string with a weight on the bottom and drop it down, where it would hang and land at 90 degrees. It's just what would be straight below it. So the third type of triangle is one that's kind of slanty, where it kind of curves back so that when you drop a weighted string, a string with a weight on the end, this would fall down this way and it would cross here like this. So this is STU. We call this spot V. So KM, PR, and TV. KM, PR, TV are altitudes. So with altitudes, when those 3 cross, they are called the orthocenter. So the orthocenter is when 3 altitudes cross. So as you could probably guess, if you start at any corner and you drop a string with a weight on the bottom, it can cross perpendicular to the opposite side 3 different times, like this. And this spot right here is called the orthocenter. Unfortunately, there's like not a lot that's super interesting or helpful about this. So I'll do these 2 examples and then I'll show you the document that I tried to put together. It's not as helpful if it's not you making it, but since we're not necessarily in the building, it's just nice to have it at least so you have an idea of how to organize. So first example says, in triangle ABC, Q is the centroid. Okay, so centroid, what you're going to want to do is look back and see, what is a centroid? A centroid is 3 medians crossing, and what's interesting about it is this little nugget right here. Okay, so it says BE is 9. That orange line is 9. Find the length of BQ and QE. BQ and QE. Well, remember from the vertex to the centroid is 2/3, and then the other 1/3 is from the centroid to the edge. So there's 2 ways you guys could think about that. I'll just draw pictures for those of you that are visual. So if this is the vertex, and this is the side, and this is the centroid, if we split it into thirds, we're looking at 1 like that, and this would be like 3, 3, 3, because it's 9 altogether. So that makes 9. That means from the vertex to the centroid, which is the vertex to the centroid, this is 6. So BQ is 6. And then QE is the centroid to the side, the centroid to the side. That's the other 3. Okay. Or if you don't like visuals, BQ is the longer one, so you would do 2/3, 2/3 of 9, which is 6, 1/3 of 9, which is 3. I feel like those are probably the two kind of easiest ways to think about it. All right. Then the last example we have here says that if segment CG is 5x minus 20, so CG is 5x minus 20, and FG is 2x plus 5. FG is 2x plus 5. What is the length of CG and FG? Well, what I'm looking at here is I'm looking at some lines that cross in the middle, and so I'm going to try to figure out what these lines are, what this middle right here, what this is. Well, they're all coming from the corners, and they're not marked as being 90 degrees. And you can pretty well tell that this one, for example, is definitely not 90 degrees. So that means this must be a centroid. So here's the thing that might be a little bit hard for you. I want you to listen to it. I'll try to repeat it twice, but just listen to it and see if you can absorb. So this green section is double the length of the small part. This green section is twice as big. So I'm going to just draw this off to the side. If we had this, for example, and this was 5 units long, and I told you that this is double, you'd say 10, right? Because you would do 5 times 2. Or if I said, like, this is 6, this is 12. This one is double, so you would do 2 times 12, and you would get 24, right? So you just double the small number. So what we know is that double the small one is the same as the big one. Oh shoot, that's a minus 20. Sorry, you guys. It's a 5x minus 20. So again, to find the long side, you need to double the small side. So we're going to double the small side and set it equal to this. So we get 4x plus 10 equals 5x minus 20. And then we want to solve, so minus 4x. And you get, 10 equals x minus 20. Add 20, add 20. And you get 30 equals x. And we have to figure out if we answered the question, and we did not, because they want to know what is the length of CG and FG. So CG is going to be 5x minus 20, or 5 times 30 minus 20, which is 150 minus 20, and that's 130. So that's 130. And then FG is 2x plus 5, or 2 times 30 plus 5, which is 60 plus 5, which is 65. And you can double check, is this long side double the length of the short side? Yes, it is. So FG is 65. Did we answer all the questions? What's the length of this? Yep. So that's what we would need to figure out this. So normally I would have you guys write down the summary of the centroid and the altitude, the orthocenter, I mean. But I tried to kind of put it all into one place. right here. So these were from 5.1, circumcenter and incenter. So this is just kind of a summary. So circumcenter, what is intersecting? It's perpendicular bisectors. It's from the side at 90-degree angles until they cross, basically. The lines come from the side. Okay, the lines come from the side. And then what's important is that if it comes from the side, then the distance to the corners are equal. Okay, so again, the lines come from the sides, then the distance to the corners are equal. For incenter, what's intersecting is the angle bisectors. These lines come from the corners, and then the distance to the sides are equal. So it's the reverse. Here comes from the sides, distance to the corner. Here comes from the corner, distance to the sides are equal. Okay, so that's the big thing with those ones. That's what you want to look for, is where the lines are coming from sometimes to figure out what it is you're looking at, whether it's a circumcenter or an incenter. Then the centroid is what we were just talking about and doing examples with. That's when the medians cross. It's from the angle to the middle of the opposite side. That's what they are. The reason we care about it, why is it useful, is again from the vertex or the corner to the centroid. It's 2/3 the length, and then it's 1/3 the rest of the way. So for example, if you have a 15 unit long segment, then this part's 10 and this part's 5, totaling up to 15. And then last is orthocenter, which is altitudes crossing from the corner to the other side and hits 90 degrees. It hits at 90 degrees. That's basically what we're looking at. That's the one where like there's different ones. You can drop outside like this. Why is it useful? I don't know. It's not super useful. At least not in our context. So this is 5.2. If you guys would like, you can take a picture of this. I can undo these drawings. You can take a picture and you can annotate however you'd like. But this might be helpful to you as you are working on your assignments or your homework. Maybe just take a picture or don't. It's totally up to you. Just thought it might be a little bit helpful.